Bismillahirrahmanirrahim. In this lecture, we will discuss applications of matter carbonyls. First of all, we will be talking about uses of metal carbonyls in organic synthesis. First, we have carbonylation reaction. Carbonylation of alkenes is an important industrial process. It includes hydroformylation and hydrosilylation of alkene. Hydroformylation reaction leads to the formation of aldehyde from alkenes, CO, H2 and TM carbonyl. So here you can see that we have alkene. When it reacts with CO and H2 in the presence of CO2, this is cobalt, alright, and this is CO8, carbon oxygen, and at 100 to 200 degrees Celsius, it converts into these two reactants, these two products. Similarly, we have another reaction. You can see that here we have alkene. When it reacts with 3CO and 2H2O in the presence of FeCO5, so we can see that an alcohol is obtained along with 2CO2. So straight chain terminal olefins are more reactive than branch chain olefins. Next we have carboxylation reaction. This reaction involves the conversion of alkenes and alkynes into carboxylic acids or their derivatives. The industrially important reprocess is used in the synthesis of beta unsaturated esters from alkynes. So here you can see that alkyne on reaction with CO and ROH in the presence of NiCO4, ester formation takes place. Next we have olefin isomerization. You may also call it alkene isomerization. Some alkenes can be isomerized in the presence of metal carbonyls. The carbonyls can act as catalyst. So here you can see we had 1,5-octadiene in the presence of metal carbonyls, and at 115 degrees Celsius it converted into 1,3-octadiene. It is basically cyclooctadiene. So you can see the conversion here. Next we have coupling and cyclization reaction. This is an important process in organic synthesis. The coupling of alkyl halides to form longer chain hydrocarbons. NiCO4 is an important reagent for coupling of alkyl halides. You can see the reaction here. Reactions of acetylene and iron carbonyl can yield benzene derivatives and many other compounds. Here you can see acetylene and iron carbonyl, and we have achieved this product here. You can see that 4 benzenes are placed on this cyclobutadiene ring, and here we have iron carbonyl FeCO3, which is attached in this way through these pi bonds. So this is a very useful technique of preparing such products. This cyclization reaction is very useful for preparing substituted benzenes. So here you can see we have alkyne. When it reacts with this metal carbonyl, it forms this product. Next, we have formation of functional groups. Metal carbonyls are used to synthesize organic molecules containing a particular functional group. For example, here you can see this carbon. On this carbon, there are two chlorine atoms and two benzene. When it reacts with this reactant, this metal carbonyl, it forms this alkene plus CO and COCl2. Similarly, in this reaction, you can see that C6H5X on reaction with metal carbonyl in the presence of THF, it yields these products. Next, we have stabilization of reaction intermediates. The one of the most important applications that metal carbonyls can stabilize unstable organic intermediates. For example, cyclobutadiene can be isolated and characterized as an iron tricarbonyl complex. For example, here you can see we have substituted cyclobutene, and when it reacts with Fe2CO9 in the presence of benzene at 50 degrees Celsius, it yields cyclobutadiene. And in the last, we have homogeneous hydrogenation catalysis. Metal carbonyls are soluble in organic solvents and can function as homogeneous catalyst. COCO8, keep in mind that this is cobalt and these are carbon oxygen, right? COCO8 in the presence of H2 and CO reduces aldehydes to alcohols. Some other functional groups such as imines, nitriles, nitroalkyls can also be reduced. So I assume that you liked this lecture. For more important lectures and videos, subscribe to our channel What's Chemistry on YouTube and press the bell icon. Thank you.